try and have a look. All right. Hello. Let's have a look at the optimal solution. So that's the solution to this. The optimal solution, that's an easy question, of course, because you can simply read it off this tableau. And you get that x1 is 10, and both x2 and x3, which because they're not in the basis, they're 0. If you're interested in the slack variables, s1 is 20, s2 not in the basis is 0, and the objective z is 20 in the solution. Okay, so that's very straightforward. Okay, proving that this thing is optimal that was a bit of a tricky question, perhaps. So I've suggested that you shouldn't try to do it. But a way of proving that a solution is optimal and there can't be any better feasible solution is, well, how do you know that from the tableau? How do you know that you have found an optimal solution? Well, you know because all these values are non-negative. Right? So that's key. And we should also remember that the objective row is in the tableau because when we were doing the Simplex method as simultaneous equations, there was a special equation there, wasn't there? And the equation was that 0 times x1 plus 1 times x2 plus 1 times x3 plus 0 times s1 plus 2 s2 plus z. So that one could have a column here, which is for the variable z, but we don't write it because it's always 0, 0, 0, 1. So we just ignore it. So plus z is equal to 20. Okay, and so this is satisfied by any feasible solution. Right? Because any feasible solution satisfies all those simultaneous equations, and this is one of them. And if you put z to one side and everything else to the other side, you get that z equals 20, take away x2, take away x3, take away 2s2. But you know that x2 is non-negative, x3 is non-negative, and s2 is non-negative. Well, I wrote because, but I didn't write what is because of that. So you start with 20. And you start with 20. You take away something that can't be negative. You take away something that can't be negative. And you take away something that can't be negative. So this whole expression can't definitely be more than 20. Right? They're all 0, and this is exactly 20. But if some of them are positive, it's going to be less than 20. So z can never be more than 20. So this is the end of the proof, really, because what it proves is that the objective can never be more than 20, and we have a solution where it's 20, so it must be optimal. Can't be a better one. Make any sense? Hope it does. And so the key to proving that the tableau is optimal, as we all know, is in the objective row. So negative values in the objective row, we still pivot, and if there are none, we say it's optimal. And this is why. Okay. Now the next thing that happened is we were asked to add a new decision variable x4, and the crucial numbers. Oh no, what am I doing? Why am I putting a 0 there? It's got to be a 1. So this is a 1. So you have 5 in the objective as the coefficient. Is that large enough to see for everybody? Yeah. So we have 5, and then we have 1 and 2. Okay. And so if you wanted in matrices, I don't know. If you wanted in matrices, some people have done it by multiplying matrices. So what you have done is probably you take this matrix, which we always called MP inverse. Okay. And so this matrix 1, 0, minus 1, 1 is multiplied by the coefficients in the constraint, which were 1 and 2. So we had 1 in the first constraint and 2 in the second constraint. Okay, and you get 1 minus 2 is minus 1, and 0 plus 2 is 2. And this gives you the values here, minus 1 and 2. Okay, you could also say that you take, because the coefficients are 1 and 2, you take 1 times this column and 2 times this column. That's what you get. That's what this matrix multiplication does anyway. Okay? And for the objective row, it's done in a similar way. So I'll just extend it because this extends to this bit, so 0 and 2. And if you times it by 1 and 2, you're going to get 4. Is it right? Yeah. So now one would be tempted to say that this is going to be 4, but it's not going to be 4. Because which bit of information did we use? We didn't use the 5 from the objective. Okay. So you were starting the tableau with a negative 5 when you're starting pivoting in the first tableau. And that negative 5 kind of you always have to add to it. So what you get here is 4 minus the 5 from the, so this is this 4 from here. And that 5 is from the red column, yeah, from the objective. So you get minus 1 here. Now these were negative, but that's an error. They shouldn't be negative. So when you add a new decision variable, either it so happens that the decision variable doesn't have any influence at all if this happens to be 0 or positive, and then you don't do anything else anymore. But if like here, this entry here is negative, minus 1 in this case, you need to do a pivot step because it's no longer optimal. Okay, so the way you do the pivot step is you look for something positive, and the only positive thing you can find is 2. So 2 is necessarily the pivot element. So what's supposed to happen is x1 is replaced by x4 in the basis, s1 stays in the basis. The whole x4 row is just a half of what it was, so it should be 5, 1 half, 2, minus 1 half, 1, 0, 1 half. And if you do the row reductions, you get 25, 1 half, 1, 9 over 2, 0, 1, minus 1 half. And the objective row is now 25, 1 half, 3, 1 half, 0, 0, 5 over 2. So the new optimal solution straight from this tableau is x1 and x2 and x3 are all naught. X4 is 5. S1 is naught. Sorry, S1 is 25. S2 is naught. And the new value of the new optimal value of the objective is 25. Okay. I think. If my notes are correct. Okay, any questions about this exercise? Okay, we've covered changing the right-hand sides. We've covered adding a new decision variable, and the next thing on the list, I think, was adding a new constraint. So adding a new constraint is what we should learn today. And that is important because of the things we'll see. Well, not only because of the things we'll see in the second term, because it's one of possible ways how to solve integer problems where you require the variables to be integer, is by adding more and more constraints until you had an integer solution. Okay, so we'll be doing some of that in the second term, and therefore it's important to know what to do. I forget what I want to do. Okay, I'm not sure. I can't remember the legend about why I wanted to add a new constraint. Anyway, the exercise here is, or the example on which we're learning how to add a new constraint is, we want to add a constraint which is x1 plus 2x2 is less than or equal to 90 for some reason, or whatever the reason is.
Are the constraints like this many people can only make this many boxes in a day?
Could be, yeah.
Right.
Something like that. Not, yeah. Just trying to concentrate on how you do it in the Tableau for the moment, but of course there is some reason for it coming from somewhere. But let's ignore that for the moment. Yeah, you can think of people don't want to buy too many. Or I probably put some reason in the book when I was writing it. I can't remember. Oh yeah. Well, in the book it says it has been discovered that the production of sets is running out of paint to coat the pieces. So we only have 90 tins of paint, and you need 2 for a large set and 1 for a small set. Okay. So you come up with something like this, but the real purpose is to learn how to do the mathematical bit now. Okay, so what happens when you do a new constraint? Well, firstly, of course, the constraint, because it's a less than or equal to, it's going to need a new slack variable, right? So this constraint is in fact going to be x1 plus 2x2 plus s4 is equal to 90. So new slack variable. And that is a bit of a problem because everything we were doing so far was dependent on knowing the inverse MB inverse matrix. Okay? Now, the MB inverse matrix is no longer going to be 3 by 3, it's going to be 4 by 4. So we could try and compute it from scratch from the old matrix. That's possible. So that's one way of doing it. Where you do the new inverse matrix, but there is another way, which is perhaps a bit simpler, which goes like this. So you fit, yeah. So when I look at the new constraint, now I don't really know. Well, another question. So the second question. The first question was how does the MB inverse change? Okay, the second question really is, maybe which should precede that one, is I need another variable to put into the basis. Because I have as many basic variables as there are constraints. Now there are 4, so I need another variable to put into the basis. So the standard way of dealing with it is that the new slack variable goes into the basis. So I put S4 into the basis, and the other ones I just keep from before. Okay. Now, the easy way of getting the new tableau is that I don't write the new tableau right away, but I do something which is kind of a hybrid thing, which means that I'll just put the new constraint into it as a constraint, as an equation. So the right-hand side is 90. There's 1x1, there's 2x2, no s1, no s2, no s3, and there's 1x4. Okay, so I'll just write it like this. Now, we know that x2 is in the basis and x1 is in the basis, so I can't have 1 and 2 here, but for the moment, I'll just keep it there. And all the other ones, they just correspond to equations, so they're going to stay the same. So I have 20, 0, 0, 1, 1/3, minus 20 thirds, and nothing. And everything else is just copied. X1 was 16, 1, 0, 0, minus 1/3, 8/3, 0. And the objective was 160, 0, 0, 0, 5/3, 8/3, 0, 1, 1. Ooh, it's gone away. All right, so what I've done here is just a copy of the tableau we had before, but adding the new constraint into its own row. And I don't like it because it's not a simplex tableau. Because I want the 0 there, I want the 0 there, so I do row reductions to get zeros. Okay, so everything is fine, really. Only the 4th row. So now I want the new row 4 to be the old row 4. Take away what? 1 times row 3 and 2 times row 2 as a row reduction, because I want to get rid of the 1 and the 2. So after I've done this, there's S1, X2, X1 and S4 still in the basis. And the only thing that changes is the S4 row, which is going to be minus 18, 0, 0, 0, minus 1/3, minus 4/3, and 1. Hope that's correct. Looks all right. Okay, the rest of the tableau stays the same. So now, what's the problem with it?
Negative mark.
Yeah, negative 18. So what do? As always, a dual pivot. Where do we do it? Well, there are 2 options. Yeah, How do we do the dual pivot again? It's always the same.
You pick the negative one, but
Yeah, you pick one of the negative ones, so it's this one or that one. Yeah. And to get it, you need the ratio test. So you look at 5/3, 80/3. You take the absolute values, so you have 5/3 divided by 1/3, which I believe is 5. And you have 80/3 divided by 4/3, which I believe is 20. And you go for the least ratio. So that's the pivot element. And this is now in the book. So apparently after pivoting, what's the basis going to be like? Well, S1, X2, and X1 remain. S4 is replaced with S2. Turns out that the vowels are 2, 28, 34, 54, and 1070 apparently. But what's more important is the objective row is 0, 0, 0, 0, 20, and 5. And the rest you can find in the book. Or do it on your own. Okay. And that's everything, because now we've got everything we need. All the right-hand sides are now positive. The objective row has no negative numbers in it. It shouldn't have any. And so that's how you add a constraint. Okay. Just as a reminder question, why do we do the ratio test again? What's the point of it? Why can't we take the other one? Or can we take the other one? Yeah, exactly. If we took this one, that would be negative after pivoting. So we'd have to do, so it wouldn't be optimal, but we don't want that. That's the purpose of doing the ratios in this case. Okay, anything else that you need to know about adding a new constraint? Fairly straightforward, just add it, row reduce. Might need to dual pivot several times. So in this case, we were lucky. After one pivot step, we already got all right-hand sides positive. It might happen in some cases that you need to do several ones before you get feasible track load. So if that does happen, don't panic. It's natural. But other than that, we've seen how to do it. You have a homework problem. If there are no more questions, I don't think that's enough for today.